Welcome back. In this last segment, we're going to look at a counterexample, that is, an incorrect proof by strong induction. So consider the following theorem. Let P of n denote the fact that any debt of n dollars can be repaid with only $2 bills. So the theorem states that for all n greater than or equal to 4, P of n is true. So we're going to write a proof by strong induction on n. First, the basis step. So we're going to start at P of 4. So let's say you have a debt of $4. Well, clearly you can repay it using exactly two $2 bills. Therefore, P of 4 holds. Then we go to the inductive step. And in that step, we're going to start by assuming that any debt whose amount is k minus 1 and k dollars can be repaid with only $2 bills. So by the induction or inductive hypothesis, we know that any debt of k minus $1 can be repaid with a certain number of $2 bills. Let's call that number of $2 bills x. Well, if these x $2 bills amount to a total k minus $1, then we can just add one more $2 bills to total k plus 1. So any debt of k plus $1 then can be repaid with exactly x plus 1 $2 bills. In other words, we just proved P of k plus 1. And that concludes the proof of the inductive step, which, together with the basis step, prove this theorem. So hopefully you figured out what's wrong with this proof. It's got to be wrong because this theorem does not even hold. So to do that, let's go through the definition of the inference rule for strong induction. That is, we must define explicitly the values of A and B. Well, according to the theorem, the value of A is 4. We're starting at n equals 4. Now, what is the value of B? Well, because we assume P of k minus 1 holds in addition to P of k, B has to be equal to 1. And that's where the problem is. If B is equal to 1, then the basis step should include not only P of 4, but also P of 4 plus 1, or P of 5. So we're missing P of 5 here. And the problem is, of course, we're not going to be able to prove P of 5, because if you have a debt of $5, which is an odd number, you're never going to be able to repay it using only $2 bills, since you can only get an even number by using $2 bills. So this proof is not only incomplete, it's completely incorrect, since you can never prove P of 5, and in fact, the theorem is not even true.